Hi, I'm Garima and I'm going to talk about the design of CPU and how this is translated into the HDL code. This is the introduction part of Hack CPU. This is a simplified architecture of CPU implementation. This is the Hack CPU implementation in which we can see that ALU gives an output that is written to data memory. In order to do so, the ALU must specify a few things. First, the content that the CPU are going to write in the data memory, which is stored in the outem. Second, the address of the write operation in the data memory. Basically, this is where you can put the content in the data memory. Lastly, the output that allows CPU to write the content to the data memory, write. The program counter holds the address of the next instruction, which would be done fetch, decay, decodes, and executed by the CPU in the next cycle. Now we identify the input and output of CPU architecture. We can now implement the CPU code. This is the HDL code of CPU. Here we have the header part. Here we have the header section which specify the CPU interface. It consists of chip name, the names of input and output pins. The input pins of CPU will consist of 16 bits in M, 16-bit instruction, and reset. On the other hand, the output pin of CPU will consist of 16-bit out-M, write-M, and 15-bit address and 15-bit PC. In the next part of CPU, as you can see, we have three different gates: NOT, in, not in, and mux16 gate. Firstly, there are two types of instruction coming out from CPU. It's the instruction memory. These instructions are A instruction and C instruction. Here I can explain A instruction and C instruction. These are the CPU operations that we are going to study in this slide. A instruction is a symbolic syntax at value. If a value is a number, the content of the A register is set to the value. If a value is a symbol, the content of A register is set to the value that the symbol points to. C instruction symbolic syntax. Dest equals to come, jump, where dest is the destination register, comp is the computation code, jump is the jump derivative. Here, this is the another part of the CPU HDL code. In the first line, not gate In the first line, NOT gate is used to tell that the instruction coming into the CPU from the instruction memory is an A instruction. AND gate to determine the instruction is C instruction, and 16-bit multiplexer is also used to select whether the instruction or the ALU output is stored in the value of A register. Then OR. In the second part of the code, we have OR gate. The load pin in the A register would be 1 if either the A instruction or the ALU output is fetched to A. In other hand, A register is used to store value that is fetched into the A register. It takes in the output A register in from the multiplexer in the output load A from the OR gate as input. The output A out then generate the content or the value inside the A register. Mux16B. Next is another Mux16 which takes in the output of A register and the value that is correctly selected in the data memory registered in M. This was sequence A to output A or M. Either A or M was fetched into the ALU depending on the 12-bit 12-bit instruction value. The AND gate is implemented implied to determine the ALU output is loaded to the D register. The D register is then implemented to the load and store the value of D register from the ALU. Next step is the ALU gate. ALU computes a function on two inputs, which in this case would be the value that is stored in the D register, and the value either A or M register, and then generate outputs. It consists of input control bits such as the ZX, NX, ZX, NX, ZY, NY, F, NO, which are indicators of which function is computed on the second on the two input to produce output, whereas the output control bits such as ZR, NG determines the property of the result. The following code The following code, which consists of 2 or 16 and an AND gate, sets the ALU outputs in order to successfully write on the data memory. The first or 16 code line determines the address of write operation. The second one determines the content of the data memory. And lastly, the AND gate output the value that allows the CPU to write the content to the data memory. The program counter, also known as PC, is the register which contains the address of instruction to the fetch next. In this part of code, the load bit of the PC is determined by the jump bits and the ALU outputs. Basically, these lines of code determines the jump conditions and checks the ALU out. See if the conditions are met. If the instruction is C instruction and the conditions are met, the PC is loaded with value that will ask to CPU jump to specify the value or symbol. If the PC is not loaded, then PC is incremented. Incrementing means the CPU read next instruction, and so this is how I understand the CPU implementation. This is the summary. This is how CPU hack CPU works and how to implement our HDL file in CPU code. An idea is nothing. Its implementation is everything we got from this slide. Thank you.